Suppose a, b, and c are integers and x, y, and z are non-zero real numbers that satisfy the following equations. Is x rational? If so, express it as a ratio of two integers. Now this is a yes or no question, and if the answer is yes, we just have to produce the ratio of two integers. So we don't have to prove anything, which is kind of nice here. So the trick is to take each of these fractions and divide both the numerator and denominator by the numerator. So we can write the first equation here as x over y divided by x over y over x divided by x over y plus y divided by x over y. And this equals a. We can cancel some of these off to make that a 1. These x's cancel and these y's cancel. So that's a 1, that's a 1. And so this is the same thing as 1 over y plus 1 over x equals a. And if we take the reciprocal of both sides, this says that 1 over y plus 1 over x equals 1 over a. We can apply the same trick to the second equation to get that 1 over z plus 1 over x equals 1 over b. And with the third equation, we get 1 over z plus 1 over y equals 1 over c. So now the next trick is to add these two equations together. So on the left-hand side, we have a 1 over x plus a 1 over x, which is 2 over x, and then plus 1 over z and 1 over y. And on the right-hand side, we have 1 over a plus 1 over b. The next thing to notice is that 1 over z plus 1 over y is 1 over c. So we can rewrite this as 2 over x plus 1 over c equals 1 over a plus 1 over b. And if you notice here, now we have an equation where there are no y's or z's. Keep in mind that y and z are non-zero real numbers. So they could be pi, they could be the square root of 2. They don't have to be rational numbers. But now that we've gotten rid of those potentially irrational numbers from this equation, we don't have to worry about y or z anymore. We can just worry about a, b, and c, which are just integers. So now I'm going to try to solve for x. And the way I'm going to do that is I'm going to combine fractions on both sides of the equation. On the left-hand side, we have 2c plus x all over x times c. And on the right-hand side, we have b plus a over ab. Next, we can do some cross multiplication to get 2abc plus abx equals bcx plus acx. We could subtract abx on both sides to get 2abc equals bcx plus acx minus abx. Next, we can factor out an x on the right-hand side. So we would have x times bc plus ac minus ab. And next, we can divide both sides by bc plus ac minus ab so that those two factors cancel. And now I'm left with x equals 2abc all over bc plus ac minus ab. Now the integers are closed under multiplications, additions, and subtractions. So the numerator here is an integer because a, b, and c are all integers. And if you multiply 4 integers together, you'll get an integer. In the denominator, a, b, and c are all integers. So if we do all these multiplications, additions, and subtractions, we'll get an integer. So x is equal to an integer divided by an integer, which means that x is a rational number. This is a really tricky problem to solve. Thanks everyone, and I'll see you in the next video.